Okay, so what we're doing is we're continuing with polynomials. We're going to do like terms now. Like terms. This is really quite easy, guys. What is it? Second today, isn't it? November 2nd. Like terms, and I'll define this, guys. I'll write the definition down, then I'll give you examples. I find it way easier to figure this stuff out when there's examples, right? Sometimes the definitions don't make sense, right? So definition, here we go. Definition. Like terms have the same variable Guys, what's the variable again? Variable is just a letter. That's all it is. Okay, it's just a letter. Okay? Like terms have the same variable raised to the same exponent. Okay? So that's the key there, guys. It has to be the same variable, right? So they both have to be x's, let's say. And they have to be raised to the same exponent. So they both have to be x squared. Like you can't have an x squared and an x cubed. That doesn't work, right? So let's give some examples here and we'll see. For examples, 2x squared. Okay. Is this a term?
Yeah.
Yeah. It's a monomial.
Yeah.
But what is the variable? X. What is the coefficient? 2. And what is the exponent? 2. Okay. So that's one right there. Now, what I want is another term that's like this one.
3x, 3y, 3.
Okay, hang on a sec. Let's write this right down. 3y, 3. First off, same variable? No. Raised to the same exponent? No. So that's not a like term. No dice. Okay, so 3x2. Okay, so here's another one. 3x squared. Okay, same variable?
Yeah.
Raised to the same exponent?
No.
Yeah, they're both 2's.
Yeah.
Can the coefficients be different?
Yeah.
Yeah, who cares? I didn't say anything about the coefficients. Do you see that? Do you see why it's the same now compared to what you gave me?
Yeah.
Okay. Can you have negatives?
Yeah.
Could you have fractions in front too? So you could have 1/2. What would the rest have to be?
X to the power of 2.
Okay, that part has to be the same. Okay. Yeah? Make sense? So what are unlike terms then?
What I said earlier,
Yeah, but why?
because they're not the same
Not the same,
variable term.
not the same variable and not raised to the same
Power.
exponents. Okay, you're getting there. All right. Let's just be clear about that. All right, so these are called unlike terms. Unlike terms. Definition. Terms with different, I'll get out of the way in a sec. Terms with different variables terms with different variables, or, and I'll do this so you can see this, or the same variables but different exponents. Right? They could have the same variables, but they could be different exponents, like an x squared and an x cubed, right? Those are unlike terms. Or the same variable with different exponents. Okay. So what did you give me before? 100.
3y3.
3y3. Okay, we'll use that one. Good. So what I want now is I want another term that's unlike to this one. Okay, so that one looks really similar, doesn't it? Look, 3y cubed and 3y2. They look similar, but are they unlike terms? Yeah, they have the same variable, but they have different exponents. That works. Can we try a different variable? Yeah? Give me something else.
3.
No, let's get rid of the coefficients 3. Let's try something really different. 2.
1.
Well, no, that's the same that's the same variable. I said with different. Okay, 2W. Do we need the 1 up there?
Yeah.
No, we don't. Is that a different term? Are these like terms at all? No, think of this as
Oh.
3 yellow submarines, and those are watermelons, 2 watermelons, right? You don't usually mix watermelons and submarines,
Well, you could take one.
because that'd be really weird.
You could put a watermelon in a cup.
Okay, thank you. You could try. Okay, now what we're going to do, guys, is we're going to take the like terms, we're going to collect them. That's all we're going to do. Can we collect the unlike terms? We can only collect the like terms. That's what we're going to do. Okay, here we go. You guys have this? I have 1, 2, 3, 4, 5. 5 quick examples with this one. No. You have this now? Or you do something else? No, you do something else. Okay. So what it's going to be is simplify. When you see that, it's going to mean collect like terms. That's what it means when you see simplify. Terms. Okay. There we go. First example. X plus 3x. This is really quite easy, guys. You go to the hospital. You get 1 x-ray. Right? They call you up and they go, uh-oh, something's wrong, and you go back and get 3 more x-rays. How many x-rays did you have in total? 4 x-rays. Okay, so you have to look at this. Are they like terms? Are they the same variable raised to the same power or exponent? Both are x's raised to the exponent 1. Okay, so this does work. So when we combine this, we end up with 4x. Easy?
Yeah.
Not that hard, eh? Okay. What about this one? You had 3 bananas. Mr. Bolton came along and stole one of your bananas. How many bananas do you have? So you have 2
Bananas.
2 bananas, 2B. That makes sense?
Yeah.
Both are the same, right? Same variables raised to the same exponent. Take it a 1 away. Okay? Two y plus y minus 4. Uh-oh. Yep.
2 submarines.
Okay.
1 submarine.
Now hang on a sec. We have how many terms here, by the way? How many terms? 3 terms. There's only 2 that you can collect, the y's, right? Because this negative 4 is known as a constant. No. Constant is by itself. The 2 in front of the y is the coefficient. Okay. So we have 2 of those and 1 of those. Can we combine those together?
Yeah.
3y. And what about the negative 4? Okay, it's just by itself. Now, do you think a common mistake is to try to put the negative 4 into this? Yes, I see that a lot, right? You have to be careful of that. Only combine them when the terms are the same. Same variable raised to the same exponent. Okay, now what happens is when they start to get larger? How do you keep track of this mess?
Hard.
No, it's actually quite easy. Watch. How many terms?
5.
5. Oh. How do you keep track of them?
So
You look
put
at
X
the-
together and the Y
You look at the
together.
variables.
Okay, you look at the variables. You put the x's together, you put the y's together. But how, I'm going to show you a method to keep track of this. You don't have to do it this way, but I find it works really well. If you have a different colored pencil or pen, or you do different shapes. So what I'm going to do is I'm going to do different shapes here. So I'm going to go with the 5 x's, and I'm going to put a box around it. So where else am I going to put a box around?
2X.
Now careful, not just the 2x, but the negative 2x, right? There it is there. Okay, so can we do that one? 5 x-rays minus 2 x-rays is
3X.
3 x-rays. Okay? I'll do a different shape. I'll do circles around this one. Negative 6y plus 2y. Does that make sense?
Yeah.
So negative 6 plus 2. Careful. Negative 6 plus 2.
Negative 6 submarine.
No. Negative
4.
4y. And what about the 1 by itself?
You just leave that.
The constant's by itself, so you just add the 1. You can do this with lines too. You could put a single line under the x's and then put double lines under the y's. I don't care how you do it. You can cross them off as you go through them. You cross off the 5x and the 2x because you can put those together. Doesn't matter to me how you do it. Everyone does it differently. But try to figure out some method for yourself to do this. Okay? Still writing that down? Yeah. Let's make sure he's done. Last one I'm going to give you is 1, 2, 3, 4, 5, 6, 7 terms. 7. I'm going to change it a bit too. It'll make it a little more difficult for you guys. You got this now? Nope, no, he's still good. Relax. No, there he is. Now he's done. I just wanted to make sure you got this before I moved up on the page. Okay, here we go. Negative 11 plus a squared minus 2c plus 16 plus 3a squared minus b minus 5c. Okay, I'll get out of the way so you can actually write that down. That's going to take a minute to write down. I'm glad you're writing this down, Ava. Anybody? I changed it from there. Still easy. There's still 7 terms. Take a second, or a couple seconds, and see if you can simplify that. Collect as many terms as you can. If you get it right, you should end up with 4 terms at the end. 4 terms if you get it right. Give it a shot. Let's do that. Do you need a pencil? Here. Just here. Here's an example. Stephen, write this down. Okay? Do our method you want. Use colored pencils, use underlines, use boxes, shapes, anything you want. Uh-huh. That way I'll just save the lesson, and if the people that missed it today, you can watch it online. It'll be on YouTube.
Do you do that for every?
I do it for my pre-cal class, but I should start doing it for you guys because we're starting to miss a lot of students. So.
Because it's Friday.
Not because it's Friday.
Oh, yeah.
Okay.
There's a play at volleyball.
No, I know.
Thing going on that's awesome.
Ryan's
Well, yeah, they look at they like put parents at the rooftop sign and they're like volleyball outside.
Yeah. It was for Halloween. Okay. Does somebody want to tell me how to do this one? Somebody want to take a guess? Worst that can happen is you're wrong, except for you because you have it written in front of you from my notes. Yeah, nice try. What do you think you do first? Other than don't answer. What do you think you do first? Okay, what are you doing? So you want to do the 11 and 16? So I'll box these ones. So the 11 and the 16. Those two go together, don't they? Because they're both, what's the term? Constant. Okay, so negative 11 plus 16 is? 5. Beautiful. There's our start. What are we going to do next? You want to do the a squared? Okay, we'll circle this one. A squared and 3a squared. Why are those two like terms? Same variable raised to the same
power.
exponent. Well, the whole thing is called the power, right? Okay. So what's a squared plus 3a squared? 4a squared. Now, guys, can you see a common mistake there that some people may do? Instead of 4a squared, what do you think they put? 4a cubed or 4a to the 4. Do you think a lot of people add those two exponents? Yeah, it's a common mistake. I see it all the time. Think of it this way. You have 1 apple, you have 3 apples. When you add them together, you get 4 apples. You don't get 4 apples to whatever power, right? Okay, what's next? The c's? So negative 2c and negative 5c. So what's negative 2 minus 5? Negative 7c. What's left over? B, negative b. Easy? Difficult? What do you think? Okay, so what's going to happen is, when we get to the next one after this, we're going to do adding, subtracting, multiplying, and dividing all these things. Adding is, are we basically adding right now? Yeah, so that next part is going to be really, really easy. So if you finish early on Monday, you can actually go on to the next part of the chapter, which is adding polynomials. You should be able to do it quite easily. Okie doke?
Okey-dokey.
Okay, so you can start on the questions now.